Hello dear students, so now today we would move ahead in this first chapter of class 12 mathematics, that is relations and functions. So today we would be discussing the question. I think the first part of the question we have already discussed in the previous video. So this would be the second one. Three relation R1, R2, R3 and R4. These are rather, I would write here four relations. Okay, so we have here four relations R1, R2, R3 and R4 are defined on a set this as follows. State whether these relations are symmetric, reflexive and transitive or not. So we have another relation here R2, and this R2, the relation R2 contains only one ordered pair, that is AA. So clearly you can see that R2 is reflexive. Why? Because the doublet of the element is there. Okay, R1 is not containing the element B and C, etc. So only one element is there, that is AA, and its doublet is there, isn't it? So we can say that we would write here R2 is reflexive, isn't it? R2 is what? R2 is reflexive. Since what? Since AA belongs to R2, isn't it? So R2 is reflexive. Now we would check whether this R2 is symmetric or not. Now clearly you can see that R2 is symmetric also, because symmetric means if there is a ordered pair AB that belongs to the relation, then BA also should be there in the relation, isn't it? But you have only one ordered pair here, that is AA. So if AA belongs to the relation R2, then its reverse is also AA. So it is also belongs to the relation R2, isn't it? So we would call R2 is symmetric relation. R2 is symmetric relation. And it would be transitive also. Why? Because it is having only one element there. Only one ordered pair inside the relation, that is A. So if contain only one ordered pair, you would call it transitive, isn't it? So the relation containing only one element there, it would be automatically transitive. Because for three because for the transition, if a relation would be a transitive relation, for that we need the three kind of ordered pairs, two or three ordered pair. Okay, but we have only one element there, only one ordered pair is there, so you can call R2 is transitive also. R2 is transitive also. Since what? Since it contains only one element, because only one element is there, so it would be transitive also. Okay, so that was your second question. Okay, second part of the question. Now we would discuss the third part, and this is the third part of the question. We have the relation R3, and this contain only one ordered pair, that is BC. Okay, it means in R3 you have two elements now, B and C. So now can you say this R3 is reflexive? No, because the doublet is not there. BB is there? No. C is there? No, isn't it? So we would not call R3 is reflexive. So I would write here R3 is not reflexive. Why? Because since BB and CC does not belongs to the relation R3, isn't it? That is why we would call R3 as not reflex. Okay, now we would check whether this R3 is symmetric or not. Okay, symmetric means if BC is there, so CB also should be there, but CB is not there, isn't it? So I would call it R3 is not symmetric. R3 is what? R3 is not symmetric. Since what? Since CB does not belongs to the relation. If BC is there, so CB also should be there. Then only it would be the symmetric one, isn't it? So R3 is not reflexive. Now we would check whether this is transitive or not. So since again you have only one ordered pair is there, so you would call this as what? Transitive. R3 is transitive in nature. Why? Since there are only two elements, that is B and C, means having only one ordered pair, that is one ordered pair BC. This is the ordered pair. Now ordered pair is one, elements are two there. Okay, so there are only two elements. So if you have only one ordered pair, then again you would be calling such a relation as transitive relation. Okay, because for transitive we need two ordered pair at least, isn't it? But you have only one ordered pair, so you would call it as transitive. Okay, just note it down. Then we would move towards the next part of the question. Now this is the next part of the question, and the relation here R4, and it contains these three ordered pair AB, BC and CA. Now it clearly shows that it is not reflexive because the doublet is not there. Is there AA? No. Is there BB? No. Is there CC? No. So we would call R4 is not reflexive. Why? Since AA comma BB, this one ordered pair BB, and what CC does not belongs to the relation, isn't it? So that is why we would call R4 as not a reflexive relation, isn't it? Now we would check whether this relation R4 is symmetric or not. Okay, so I would call R4 would be symmetric if and only if the reverse of the elements are also there, or the reverse ordered pair is also there. Okay, so let any ordered pair I am taking, that is AB, that is there in the relation R4, isn't it? AB is there in the relation. So is there BA also? No, BA is not there. But BA does not belongs to the relation R4. So hence we would call R4 as not symmetric. So hence R4 is not symmetric relation, isn't it? R4 is not a symmetric relation, isn't it? So now let's move towards the last one, whether this R4 is transitive or not. So for transitive we need what? Let's say we have an event AB belongs to the relation R4. Then we have the element BC belongs to the relation R4. Then what does this mean? If B and B, then this A and C also should be there in the relation, but it is not there. But AC does not belongs to the relation. We have CA there, but AC is not there, isn't it? AC should be there. Okay, we have CA, but CA this is not the transitive case. AC should be there in the relation. Okay, so hence we would call R4 as not transitive. Okay, so hence R4 is not transitive, isn't it? So that is why we would do the second question. All the parts we have done, all these four parts just now you must be knowing now. Okay, now let's move ahead. Now let's move towards the next question. Question is, test whether the following relations R1, R2 and R3 are reflexive, symmetric and transitive or not. So first part of the question is, R1 on the set Q0 defined by Q0 means all the rational numbers excluding 0. Okay, the rational numbers, you would be taking here all the rational numbers, but you would not be taking here 0. So all the rational numbers excluding 0, that one set of rational numbers would be known as Q0. Okay, so R1 on Q0 defined by AB belongs to R1, belongs to what? Belongs to R1. Okay, if and only if A is equals to 1 by B. Okay, so this is the condition has been given here. The relation would be there on the set of the rational number excluding 0. The relation is here, but the condition has been given that this ordered pair can exist in the relation if this condition is being followed. Means A is equals to 1 by B. So it clearly shows that R1 is not reflexive. R1 is not reflexive. How? Since for being reflexive, A should be there in relation R1, isn't it? This is the condition for the reflexivity. Okay, so R1 would be reflexive if this AA would be there in the R1. But the condition only has been given here, if and only if A should be equals to 1 by B. But can this A be equals to 1 by A? Is it possible? Means the first element should be equals to 1 by second element. But here first element is also a, second element is also a. So can this one A would be equals to 1 by A? Is it possible? No, it cannot be possible, isn't it? So that is why we are calling at R1 as not reflexive. Why? Since A cannot be equals to 1 by A, hence AA does not belongs to the relation R1. So we would call R1 as not reflexive. Getting this or not? Because condition has been given here. This ordered pair would be there in the R relation if this condition is being followed. So this one ordered pair, because for the reflexivity the doublet should be there. So this one ordered pair should be there in the relation if and only if the first element, that A, should be equals to the 1 by of the second element, but second element is also here. So can this, is this possible? No, this cannot be equal. Okay, so hence we would call the doublet is not there in the relation. So hence we would call the relation R1 is not reflexive. Okay, now let's check whether the given relation is symmetric or not. Now just tell me whether this relation is symmetric, or just think it. How would you say that the relation is symmetric or not? Just solve it. Try it yourself. Try it yourself. For the condition for the symmetry means for being a symmetric relation is what? What? Let me take. Let A B is an ordered pair which is there in the relation. Can it be there in the relation? Yes. Since A is equals to 1 by B, that already have been given. Okay. Now just tell me whether the reverse of the relation would be there in the relation or not. Just tell me. Can this BA also belongs to the relation? Means this BA would be there in the relation R1 if condition is what? The first element should be equals to 1 by second element. Isn't it? So can this condition be followed here? No. Because A is equals to 1 by B. So how B can be equals to 1 by A? Yes, B can be equals to, just cross multiply it here. B would come here, A would go there. So I would write it as, this B would go there and A would come here. So I can write it as B is equals to 1 by A also. Isn't it? Isn't it? Isn't it? Means the second element is equals to 1 by the, sorry, first element is equals to 1 by the second element. So this condition is being followed here. Isn't it? So it means this one ordered pair is there in the relation. So hence what? Hence the relation R1 is symmetric. Hence R1 is symmetric. Isn't it? Okay. Now let's check whether the given relation is transitive or not. Okay. So for being transitive, what do you need? We take the element, let's say, let A comma B is belongs to the relation R1. It implies what? It implies what? It implies the first element should be equals to 1 by B. This condition is also being followed here. And one more element, one or more order where we are taking, let's say BC, because the first element, the second element would be the first element here. What means I'm just showing whether the relation is transitive or not. Okay. So let me take another order pair, let's say BC, and let's say BC also belongs to the relation, and it implies what? B is equals to 1 by C. Okay. Now whether this A comma C is also there in the relation, that we have to check. Now just tell me, AC also belongs to the relation, the first and the last. This also there in the relation or not? Let me check it. Means for this the A should be equals to 1 by C. The A should be equals to 1 by C. So now whether this is equals to 1 by C or not, let me find out the value now. Okay. Now from these two equations we can conclude that A is equals to 1 by B and B is equals to 1 by C. So put the value of B 1 by C here now. How much you would be getting? A would be equals to 1 by, value of B is how much here? Value of B is 1 by C. So this C would go there. So A is equals to C. We are getting A is equals to C. But we should have A is equals to 1 by C. But the condition is not being, this one condition is not being followed here. So hence this one ordered pair would not be there in the relation, as A is equals to 1 by C. Had the A is equals to 1 by C, had the A is equals to 1 by C, so then you would have called the relation as transitive relation, isn't it? So in this case the relation is not transitive. Hope you are getting this, isn't it? Yes. So I would call hence R1 is not transitive relation. Okay. Okay, that is all for today. Would be discussing the other parts of this one question, that is the third question, in the upcoming videos. Till then, stay tuned and keep watching. Thank you. Have a good day.